Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, I want to continue beam analysis using flexibility method. So this is the question. So this is indeterminate beam to the first degree of indeterminacy. Okay, this beam has one fix at A and a roller at C. So there is one redundant, and in the first part of my my previous video, I have explained about how to choose the redundant in the system. Okay, so now we want to continue. Okay, the second part of the video. Okay, we will choose one we will choose one beam possibility as the redundant. Okay, let's say I want to choose the first possibility. The first possibility means that once we choose the redundant, we will have primary beam. Okay, so the primary beam that we are going to choose is the cantilever beam. So cantilever beam is the primary beam whenever the roller is the redundant, the CY reaction at C as the redundant. So this is the first possibility. So I will choose this to analyze this beam. Okay, so okay, let's start. Okay, so I choose the first possibility as the redundant, means that CY is the redundant. So CY is redundant. Redundant is CY. Redundant is CY. Okay, redundant is CY. So we have to be able to write the compatibility equation directly. You don't have to derive the equation. You don't have to derive the equation. What you need to know is once we have chosen the redundant, we have to be able to write the compatibility equation directly. Okay, so once one thing that you should know is we will solve the redundant using compatibility equation. Means that by solving compatibility equation, we will get the redundant value. Okay, so CY is the vertical force. Okay, CY is vertical force, and the pair for the vertical force is the vertical deflection, vertical displacement or deflection. Means that the redundant, since the redundant is the vertical force at C, so we have to look at the displacement occur at position C, at position C. So by applying the principle of superposition, we will write the compatibility equation, and the compatibility equation will look like this. It is delta at position C in primary beam plus F for the flexibility coefficient, CC times CY, and this is equal to 0. So this is the compatibility equation. Means that it is very simple, straightforward. We just need to identify redundant. We just need to identify redundant. Once we have chosen the redundant, okay, we have to identify either the redundant is moment or force or a vertical force. If the vertical force is the redundant, so we have to look at the delta at redundant position, means at C. So we will have primary beam. We will also have redundant beam, and combination of redundant and the redundant and primary beam will produce actual beam. Okay, so redundant is CY. Redundant is CY, and so we have to focus at C. We have to focus at C. So the delta in primary beam is delta C naught. The delta in redundant beam is FCC times with CY. So from this, we will get the redundant value, the CY value, because delta C naught, and FCC, these two are displacement. These two are displacement at position C. One is in primary beam and another one is in redundant beam. So we will have two displacement which is come from two system, determinate system. One is from the primary beam. This is come from primary beam, and FCC is displacement due to a unique value of redundant in redundant beam. Okay, so there are two displacement, delta C naught and FCC. C naught not label is for the primary system. Whenever we see the note, the notation note, C naught, the note label C naught, this is belong to primary beam, and F means the redundant beam, at position C for redundant CY applied. So there are two displacement. The displacement is delta C naught. The displacement is FCC. One is located is in primary structure, and another one is located in redundant structure. Where it is located? It is located at C. It is delta located at C. Both delta C naught and FCC are displacement, vertical displacement. So this is very important because we have to understand that using flexibility method we use whenever the three equilibrium equation is not enough to solve for the unknown reaction. So there are more than three, there are four, there are five. So in this case, there is one redundant. So means that we have to solve this redundant value first. We have to solve one redundant. We have to solve the problem first. Okay, so how to solve the redundant? By solving compatibility equation. So what is compatibility equation? It is actually the displacement equation. Okay, the displacement in primary beam, the displacement in redundant beam, and displacement in redundant beam, we use F for the symbol, FCC. So from this this information as stated in the screen right now is actually describe the whole process. Means that we have to understand that we want to solve for the redundant. Redundant is CY. And in order to solve CY, we have to have delta C naught as well as FCC. So we have to know what is delta C naught, what is FCC. So these two belong to primary beam and redundant beam respectively. Okay, so how are we going to have this? Okay, by using formula. Okay, formula. So what is the formula? The formula to calculate delta C naught is, since this is beam, we have to consider the bending effect, EI means EI. So displacement for beam, displacement due to bending effect, we integrate moment equation. It is 1 over EI from 0 to L, 0 to L, and we have to integrate moment equation. It is actually two moment equation. Two moment equation, M times M. M times M. So it is MC M naught dx. MC M naught dx. MC M naught dx. C naught. Okay. C naught. C naught. Delta C naught means MC M naught. We integrate. We integrate. So another one is FCC. FCC means 1 over EI from 0 to L. Okay, this time because the notation is C and C, C and C, so we will have MC and MC. MC, MC, 2 MC, 2 MC. And this can be written as MC squared. MC squared dx. MC squared dx. Okay? So after this, what is the next step after this? So we will write moment equation, moment equation, MC and M naught, MC and M naught. So what is MC, what is M naught? Okay, so MC, M naught first. M naught is moment equation. Moment equation in, always remember the node symbol is for the primary system. In primary beam, and MC is the moment equation in, moment equation in redundant. What is the name of redundant? CY. Redundant CY applied. This is the name. Redundant CY applied. This is the name. Primary beam. M refers to moment equation. M refers to moment equation. One in primary beam, one is redundant beam. So this actually will guide us what is the next step. What is the next step? The next step is we have to have two cantilever beam. One is for the primary beam, one is for the redundant beam. So we have to write the moment equation for each of these beam. Okay? So this is actually flexibility method. Flexibility method. So we have to choose one possibility only. We have to choose one possibility only. We can choose CY as the redundant and solve, or we can choose MA as the redundant and solve. Okay, if redundant is CY, means that the position is C, so we have to look at the displacement located at C. Okay, so we will have three systems: primary system, redundant system, and actual system. Okay, it is primary beam plus redundant beam plus is equal to actual beam. So from that, we will write the displacement equation based on the principle of superposition. So displacement at C in primary beam is called as delta C naught, displacement at C. Delta C means displacement at C. Displacement at C for primary beam. Naught is the label for primary beam. So that is why we label as delta C naught. FCC. FCC is also deflection at C. Deflection at C. So the first notation we use for the position. The first notation is used for the position. So FCC, FC, the first C in F is the first C in F is displacement at C for redundant CY applied. We label as FCC, okay, times with CY, times with the redundant. So this is the compatibility equation. This is the compatibility equation. So there are two displacement, delta C naught and FCC. Okay, these two displacement come from two system, primary beam and redundant beam. Okay, so means that we have to have two system, and delta C naught, the formula to calculate the delta is the deflection is we have to integrate two moment equation. So MC and M naught, and delta C naught is MC M naught, and we have another one FCC. FCC means MC times MC, we write as MC squared. MC squared. So MC and M naught, these two are the moment equation. And always remember that naught is the label for primary system and MC is the moment equation in redundant CY applied. Okay, so there are two systems that we will analyze in order to solve for the redundant CY applied. System number one is called as M naught. M naught is actually moment equation in primary beam, and MC is the moment equation in redundant CY applied. So in the next video, I will show to you how we determine, how we analyze primary beam and redundant CY applied redundant beam. Okay, and we calculate reaction and writing the moment equation. Okay, so that's all. We will meet again in the next video. Thank you very much.